Alright, good afternoon everyone. As the day I'm recording this, it is exactly 7 days left to the A-Level H2 Math Paper 1 for the year 2022. So I've been busy, so sorry about that. This might be the last paper I go through, Hwa Chong. I plan to do VJC paper, but I don't think I'll have the time. So I will finish up Hwa Chong paper 1. So this time I'll be recording all of the Hwa Chong paper 1 questions in one go, and I will do the same for paper 2, along with the ACJC 2021 and Diamond High 2022 Prelim paper 2 stats questions. And hopefully I'll get those all up by the time the respective papers come out. Okay, so let's just get started. For the first question, we have inequalities. It's a very simple question. Solve this inequality algebraically. So 1a, solve x minus 1 divide by x minus 2 less than or equals to x minus 2 times over x minus 1. Okay. If I multiply the both sides so as to make a common denominator, I will get x squared minus 4x plus 4 divided by, oh sorry, this one should be x squared minus 2x plus 1. What I want to do is I'm going to multiply the top and bottom by x minus 1, so that I get the denominator x minus 1, x minus 2. This is less than or equals to, I'll do the same thing here, multiply top and bottom by x minus 2 to get x squared minus 4x plus 4 divided by x minus 1 times x minus 2. Okay, and of course you can bring everything to one side. So one will get 2x minus 3, x minus 1 times x minus 2 is less than or equals to 0. And you can solve this however you want. I'm going to use sign tests. So 1, 3 over 2, and 2. So 1 and 2 are not included, but 3 over 2 is included. And 3 over 2 is included. And if I let top and bottom be negative, then this becomes positive. This minus, this plus, and this is minus. Oh wait, sorry, this is the top is linear, the bottom is quadratic. So if you let x less than 1, the bottom will be negative, the top will be positive. So this will be negative, positive, negative, positive. So based on this, we have x less than 1 or 3 over 2 less than or equals to x less than 2. Okay, so be careful with the signs here. Given that f of x is this, state the value of a such that fx minus a is 2x minus 3 divided by 2x minus 5. For this, this is just by observation. So a equals to half. Hopefully you'll be able to observe that, because you will get x minus 3 over 2 divided by x minus 5 over 2. Top and bottom multiplied by 2 gives you the result. For the last part, we have, oh, it's actually part 1, part 2, part 3, but never mind. Hence solve this. So once again, they replace x by x minus half. So you just replace the solution set by x minus half also, so that you get x less than 3 over 2 or 2 less than or equals to x less than 5 over 2. Okay, so that's that. Question 2 is Maclaurin's. We have the equilateral triangle ABC, 2K, ABD is triangle where AD is K, CAD is X. Okay. So for the first part, we need to show that BD squared is something. So we have two sides and we know the angle between them. So angle BAD, by the way, is 60 degrees plus x, or pi over 3 plus x. Okay. So to find BD squared, we have two sides that include angles, so we use cosine rule, right? So we will get AD squared plus AB squared minus 2 ADAB 2AD AB cosine angle BAD. And this gives you k squared plus 2k squared, so this is 5k squared minus 4k squared cosine BAD, which is cosine of pi over 3 plus x. Okay, one can factor out the k squared, and you will get 5 minus, okay, so expand this, cosine pi over 3 plus x is cosine pi over 3 cosine x, which is half of, which is actually no, multiplied by the 4 outside. So we get 2 cosine x, and then the sine pi over 3 is root 3 over 2 times 4 is 2 root 3. So we add a plus 2 root 3 sine x. The thing here is that the sine part will actually be negative, but it cancels out the negative at the front. So you get the desired result. Okay. For the second part, we are going to find the Maclaurin's for BD. So BD is approximately, so we square root this, k square of this. We're going to use the small angle approximations for cosine and sine. So what I will get is 5 minus 2 plus x squared. And then for this one, sine x is approximately x, so you get plus 2 root 3 times x. Okay? And this approximation will be, the terms of x and x squared will be sufficient because we're going to use the binomial series to expand this. And we only want the term for up to x squared. So all of these terms will be sufficient. Now the problem is, if you want to use binomial series, this must be a 1. This must be a 1. So let's make this the case. We have root 5k, and we have times the square root of 1 minus, oh actually no, sorry, 5 minus 2 is 3. So we want root 3. Okay, 1 minus 1 plus, let's put the x first. So we get 1 plus 2x, or rather 2 root 3 over 3x, because we are factoring out the root 3. And then we have plus 1/3 x squared. Okay? And we use the binomial series from here. So that we get root 3k. So we start with the 1. And then the first binomial coefficient is n is half times negative half divided by, oh wait, no, it's half first. Just take the half first. Plus half. Okay. Then this is where we get the 2 root 3 divided by 3x plus 1 over 3x squared. Okay. And then you consider the n minus 1 divided by 2, which is negative 1 over 8. Now, I don't need to consider the term in x squared anymore. I just need to consider the term in x, so that I get 2 root 3 over 3x squared. Okay? And I can just consider this. Maybe I'll write this outside. Here. Okay. Okay. So let's see what we get from here. Square root of 3k. Then this is, well, I will get, the x term will be just root 3 over 3, I think. Yeah. 1 plus root 3 over 3 x. And the term in x squared, this is going to be, if you square this, you will get 4 over 3. 1/8 of that is 1 over 6. But it just so happens that if you take this one here, the x squared, 1 half times 1/3 is also 1 over 6. So the x squared is actually cancelled out. There's actually no term in x squared. Okay, So we can simplify this to k times square root 3 plus x. Yeah, that's it. There's actually no term in x squared. I think that's pretty magical. Okay, sequence and series. I think this is the method of difference one. Okay, so we have UR defined by 1 over R factorial. For the first part, I don't expect many people to have issues with the first part. UR minus 2 UR plus 1 plus UR plus 2. This is just, a bit of algebra work here. So let's see what we get. This is 1 over, we're going to make the common denominator of R plus 2 factorial. So 1 over R factorial. To get R plus 2 factorial, we need to multiply by R plus 1 and R plus 2. So let's do that. R plus 1 times R plus 2 is R squared plus 3R plus 2. Okay, and then minus 2R plus 1, R plus 2 rather, and then plus 1, divide by R plus 2 factorial. And you can go ahead and simplify this. You will still have an R squared at the top, but now your coefficient of R just becomes 3 minus 2, which is 1. So R squared plus R. Then 2 minus 4 plus 1 is negative 1. So you get that, divide by R plus 2 factorial. So this should be quite simple. Okay, then for 3 part 2, if you've done method of differences before, it should also be a no-brainer. This is quite a standard part. We notice that the sum of R equals to 1 to n, this is actually R squared plus R minus 1 divided by R plus 2 factorial. We notice that this is actually the sum of UR minus 2 UR plus 1 plus UR plus 2. So that we get the following. We'll get U1 minus 2U2 plus U3 plus U2 minus 2U3 plus U4 plus U3 minus 2U4 plus U5. And, well, you can see where this is going. UN minus 2 plus U2 UN minus 3 plus UN minus 4 plus UN minus 1 plus 2UN minus 2 plus UN minus 3 plus UN minus, wait, did I write plus here? Sorry, this should be minus. Okay. 2UN minus 1 plus UN minus 2. Okay, so you will see that we can do the cancelling. We'll cancel that, cancel that, cancel that. And similarly, we can do the cancelling for the bottom part as well. Oh wait, this is a UN. Oh, I'm dumb. Okay, this is 1. I wrote all the numbers here wrong. I was wondering what was happening. UN minus 1 plus UN. Okay, we'll leave it at that. Okay, UN plus 1. Then this one is n plus 1, n plus 2. Okay, there you go. This cancels, and so does that, and so does that. So that you are left with U1 minus U2 minus UN plus 1 plus UN plus 2. U1 minus U2, so U1 is 1 and U2 is half. So you get half minus 1 over n plus 1 factorial plus 1 over n plus 2 factorial. Okay? And sum to infinity is half. Okay? And it should be quite obvious why that would be the case. So for the last part, using expansion from the list of formulae MF26, okay, so one of the great things you need to know is that sum r equals to 0 to infinity of the series x r divided by r factorial is e to the power of x. This is the Maclaurin series for e power x, and this is in the NMAth26. Okay, so you don't need to remember this, but in our case, sum r equals to 1 to infinity of ur minus r squared plus r minus 1 divided by r plus 2 factorial. Now you will see that this is ur is 1 over r factorial. It's the case where x is 1, because no matter what the value of r is, the top will always be 1. So you will get the case e to the power of 1, but this starts from 0. And we want to exclude 0 for our sum, so it's e minus 1. So you get e minus 1 minus half, because this sum to infinity of the latter part is half, as we earlier determined. So this is e minus 3 over 2. Okay? Question 4. Okay, hyperbola. Okay, so we have this for part 1. We have, if you want, you can write the equation in standard form. X squared divided by root 3 square minus y square equals to 1. Although I suppose it's not that necessary since the numbers are quite nice anyway. And what this is going to give you is a hyperbola centered at the origin. Okay. And let's draw the asymptotes. So the asymptotes will actually be plus minus root 3. Y equals to plus minus root 3 root 3 over 3x. Because the center of the hyperbola is the origin, so the asymptotes also pass through the origin. Okay, so it turns out that you just have that. It's very nice. Let me make the thing a little bit more straight. Okay, repeat the process here. Okay, and what are the axial intercepts? Well, if you let y be 0, then x has to be root 3. So that looks something like that. Make sure that you're at the vertices of the hyperbola, it's parallel to the y-axis. It'll be a bit hard for me to draw the curve perfectly approaching the asymptote here, but you get the idea. Reflect this in the other way, and then reflect this entire thing about the y-axis. Because my tablet does move. Let me try holding it down a bit. There you go. And the same process goes over here. Oops. Okay. Make sure this is straight. Okay, so that will be roughly the shape of your hyperbola. So x squared minus 3y squared equals to 3. This is the x-axis. This is the y-axis. This is the origin. Y equals to plus minus root 3 over 3x. Sorry, this is negative. The top part is y equals to positive root 3 over 3x. Okay. The axial intercepts will be root 3 and negative root 3. A complex number has this, x plus iy. X and y are real. Given that the real part of z is positive and the relation is the same as the hyperbola, what is the behavior of the argument of z? Okay, this one is kind of interesting. So I think Daman Hai had a very similar question for this also. We actually consider the fact that the argument is tangent inverse of y over x, right? So the argument of z is tangent inverse y over x. And this applies since x and y are positive. or rather when x is positive. Y doesn't have to be y doesn't need to be positive since x is 0 from the fact that the real part of z is 0, greater than 0. Okay, so as x tends to infinity, we have y over x based on the asymptotes they tend towards. What does it tend to? Tends to root 3 over 3. Actually, it tends to plus minus root 3 over 3, right? So therefore, argument of z tends towards plus minus tangent inverse of root 3 over 3, which happens to be exactly pi over 6. Okay? So, yeah. Question 5. A function is defined as f of x is this. So, f of x is x cubed divided by x squared plus k. We shall find f prime x to be 3x squared plus k minus 2x power 4. Yes. Divided by x squared plus k squared. Okay. And we can simplify this. This is actually 3x power 4. So this is x power 4 plus 3k x squared divided by x squared plus k squared. And since x squared plus k squared greater than 0, and x power 4 plus 3kx squared equals to x squared times x squared plus 3k, which is greater than or equals to 0, f prime x greater than or equals to 0, so f of x is increasing. Note that strictly speaking, Cambridge definition of increasing function is strictly more than, but in other syllabus, they will actually tell you that an increasing function is one that is not necessarily a constant gradient. It's not necessarily excludes constant gradient. It's simply a not decreasing, meaning that it is not the case that f prime is less than 0. So more than or equals to 0 can be included, but Cambridge does not use that, does not adapt that definition. So just take note. But never mind. We now turn to the case k is negative 3 and sketch this curve. Of course, you can just use your GC to sketch it. And you will get a rotationally symmetrical curve. So what is the equation? So actually, right, take note that x cubed over x squared minus 3, I can actually divide this with long division so that I get x cubed minus 3x plus 3x, so that I get x plus 3 over 3x over x squared minus 3. And one of the things about this is that it means that the line y equals to x is an oblique asymptote, because as x tends to infinity, 3x over x squared minus 3 tends to 0. Okay, so there are also vertical asymptotes, and I think you can figure out what the vertical asymptotes will be. So let me just draw them in. x equals to, actually no, I think I'll label it on this side. X equals to negative 3 and x equals to positive root 3. Oh my. Negative root 3 and x is positive root 3 here, and yeah, and the line y equals to x, so that will be here. Okay, so this is the line y equals to x. So if you sketch the graph, you'll actually see this, it will come from this side, and then there'll be a turning point somewhere here, and then it will tend towards the vertical asymptote. And my drawing is not super accurate, but I don't think it's too bad. The one thing that my tutor personally told me was that it doesn't matter too much if your scale is like not 100% proportional, because we are doing what is called sketch, not a plot. So we just want the general shape. Proportion wise, if we want an accurate one, we can plot the graph. Okay. Take very careful note that when your curve approaches the origin, the gradient of the curve is 0. So it should have an inflection point here, and then continue downwards. A bit hard to draw for this part. It's like my tablet thinks I'm trying to do a straight line after that. Okay, something like that. And it will approach this one again, and it will turn back around, and it will approach the asymptote again. Oops. Come on, come on. Okay, there you go. And we can write down the turning points. You can use your GC to find them, although actually I think that I read the marking scheme, they actually found it by hand because of the fact that they have dy dx or f prime x. The question didn't say that you have to show your working to find the turning points, so therefore I will just personally use my GC to find them. Although, to be honest, the fact that they're asking for the turning points probably means that they are nice numbers anyway. If the numbers are not nice, they'll probably not ask you to solve by hand. Okay, so this is the origin O, and these are the turning points, asymptotes. I think that's everything. You can label the curve as this. So y equals to that. Okay. Okay. And finally, we need to, this curve has the equation x minus 3 squared over 9 plus y squared over a equals to 1. What is the range of values of a so that y intersects f of x at more than 3 points? So one of the things you need to realize is that this is an ellipse, and the width of this ellipse will be 3, and it will actually cut the origin. And you want, and the height will be the square root of a. Okay, so if I draw the ellipse, it will look something like this. The ellipse is nicely centered on the line x equals to 3, so therefore I can come back down. And what does it look like? Just imagine that I extrapolate the ellipse a bit. Okay. Same idea goes down here. I continue my ellipse. Okay. So this is the intercept that corresponds to 6. Okay, so we can see here that the 4 intersection points, one of them is the, let me mark them in red. We have the origin, we have this point, we have this point, and we have this point. And we notice that these 2 points will converge into a tangent if these 2 points converge into a tangent if a squared equals to 9/2, or rather square root of a is equals to 9/2. So let me highlight those in let me put a star on these 2 points. Okay, so star converge to 1 point if root a equals to 9/2. Okay, but we want more than 3 points, right? So clearly we need root a to be, for 4 points, clearly we see from our graph sketch, square root a has to be greater than 9/2, and therefore a has to be greater than 81/4. Yeah. Okay. Question 6. We have a piecewise function. Given that f has an inverse, determine the range of value of a. Okay. So for the f to be invertible, it must be a 1-1 function. So range of the 5 plus ln x, 0 less than x less than 1, is for ln 1 is 0, so it's actually negative infinity, and 5. Yeah, okay. Need minus x squared plus 6x is greater than or equals to 5, from which one gets x squared minus 6x plus 5 greater than or equals to 0. X minus 1, x minus 5 is greater than or equals to 0. Actually, no, I think it's the other. I think I have to flip the sign. Less than or equals to 1 less than or equals to x less than or equals to 5. But to be 1, 1, 1 less than or equals to x less than or equals to 3. Because I'll explain why. Because x squared minus 6x plus 5 is equals to x minus 3 square minus 4. Yeah. So there's a symmetry. So your a has to be between 1 and 3. Given that a satisfies this range of values, sketch the graph of f. Okay. So we have 6 part 2. And we don't actually need to draw the x-axis too far. Y, x. Okay, so we know that there will be a vertical asymptote at the y-axis, the vertical asymptote, because of the long graph. So let's draw the 5 somewhere here, if I can. Very hard to draw this part. Okay, can. So this is the f of x part, and this is the. Now we want the function to be a Now if you notice, we put 1 into both sides, you will get 5 precisely. So it will actually be a continuous point. So there's no discontinuity here. What we will actually term a jump discontinuity. But it turns out that this is continuous. So, okay. We don't need to find the axial intercept because the question didn't ask for it. But we do need the endpoints. Okay. So this is the line y equals to 0 as the vertical asymptote. And the origin Okay, so for the quadratic part, if you want to be precise, you can use your GC and you will find that the gradient here is slightly more, so you can curve it up a bit. And what will be the max point? The maximum point will be negative a squared plus 6a because we determined that the curve is increasing on that interval, so that you get something like this. Okay? You get a, and this is 6a minus a squared. Okay? And this is a included endpoint, so make it a shaded circle. So this is the curve of y equals to f of x. Okay? Yeah. Note once again that this is not a smooth curve. This part is actually, there's a kink here. The gradient here is slightly more on the right side. Okay? So one now defines f inverse in similar form. Okay. Finding the inverse of 5 plus ln x is quite simple. Actually, both functions finding the inverse is quite simple. I don't even need to do the full working. For 0 less than or less than x less than 1, f inverse x, so we let y equals to 5 plus ln x, so then x is just e power 5 minus 5. Or is it y minus 5? Yeah, it's y minus 5. So you get e x minus 5, e power x minus 5. The domain of f inverse is the range of f. So the domain will be negative infinity and 5, right? Actually, no. Actually, yes, negative infinity. So that will be negative infinity and 5. Then for 1 less than x less than a, f inverse of x. Take note that this is actually negative of x minus 3 squared plus 9. So 9 minus, so we have 9 minus y. 9 minus y equals to x minus 3 squared. And therefore x is how about I write the working out? Let y equals to negative x squared plus 6x, actually f of x equals negative x squared plus 6x, which is negative, which is 9 minus x minus 3 squared. So 9 minus y equals to x minus 3 squared. Then you can make the choice. So x is less than 3. So since x less than 3, we have x equals to 3 minus square root of 9 minus y. Therefore, f inverse of x is 3 minus square root 9 minus x. And what is the domain? Once again, it will be the range. So in this case, it's the domain of the range of the original function, not r, sorry. So that will include 5 and 6a minus a squared. Okay. So finally, we write it in similar form. So the function f of x maps x to the following. We have e power x minus 5 for x less than 5, or 3 minus root 9 minus x for 5 less than or equals to x less than 6a minus a squared, less than or equal to. Okay, so that will be the final answer. Question 7, integration. Find the integral of w squared tangent inverse w dw. Okay, so first thing will probably be integration by parts, right? So LITE, the u shall be the tangent inverse. So integrate w squared, we will get w cubed over 3 tangent inverse w minus. Now when we differentiate tangent inverse of w, you get 1 over 1 plus w squared. So you get 1/3 the integral of w cubed divided by 1 plus w squared dw. Okay. How do we do with that? We will do long division. So add a w and subtract a w. So if you add w, you get minus 1/3. So you get minus w over 3. And then you add back the thing. Actually, let me make it a bit less confusing. I'll put the 1/3 here. Integral of. Now I add a w. So that I get w. Then I subtract the same w. So that I get half. I'll put the half here so that I can get 2w divided by 1 plus w squared dw. So that I get w cubed over 3 tangent minus 1w minus w squared over 6. Alright, and then finally when I integrate this, I get plus 1 over 6 ln 1 plus w squared plus c. Let me just check. Yep. And there is no need for the modulus on the ln because of the fact that 1 plus w squared is always positive. Okay, part 2. The curve C is given by this. So if you want, you can actually sketch the curve. Let me just... And if you sketch the curve, it will actually, we can get a very simple sketch. I don't really need to do any hard work for this. I just sketch the general shape of the curve. Just looks like that. Okay, the intercept will be 1 over 3. And we have the line y equals the square root pi over 2. So this is the curve C. And what I want to do is find the volume when I rotate this region, R. Okay, so the rotated region will be this R thing. The one I'm highlighting now will be the region R. Oops. How about I do it this way? So this is the region that we want to rotate, and we're going to rotate it about the x-axis. Yeah. Okay. So how do we find this volume? Well, we can find the volume generated when we rotate the curve from 1/3 to square root pi over 2. And where is this intersection point? This turns out to actually be 2/3 exactly. And the reason for that is if you put 2/3 in here, you will get 2 minus 1, which is 1. And then tangent inverse of 1 is pi over 4. So you get square root of pi over 4, which is root pi over 2. Okay, so it's exactly 2 over 3. So what we're going to do is we're going to consider the cylinder that we get when rotating the rectangle, then subtract away the volume from the curve. So the volume will be volume of cylinder, which is root pi, which is pi r squared h, so pi over 2, pi times pi over 4 times 2 over 3. Minus the integral from 1 over 3 to 2 over 3 of y squared dx, right? Because we're using this method of integration. One simplifies this to get pi squared, 2 pi over 3. 2 over 3, not pi over 3, sorry. Okay, one gets pi squared over 6 as the volume of the cylinder. Okay, how do I integrate this? Notice that we actually found the w squared tangent inverse of w. So it's the exact same corresponding thing, except that your w is 3x minus 1. So I can sub w equals to 3x minus 1. And the only caveat is that now integrating with respect to w, I must replace my dx by dw. Dx, dw. So if w is 3x minus 1, so w is 3x minus 1, then actually to replace dx by dw, I actually just have dw dx divide by equals to just 3, right? So dw is 3 times dx. So I must take out the 1/3 here. Oh, and I forgot the pi on the outside here also. Sorry about that. Pi, okay, integrate and change the limits. So 3x minus 1, 1/3 is x equals to 0. And then 2/3 will be 1. Yeah. And then we're going to find w squared tangent inverse w dw, which we happen to already know how to integrate. So we get pi squared over 6 minus pi over 3. Okay, and I think we have w cubed over 3 tangent inverse w minus, what is it? W squared over 6 plus 1 over 6 ln 1 plus w squared. And this is going from 0 to 1. So we get pi squared over 6 minus pi over 3. Now 1/3 tangent inverse of 1 is pi over 12. So we get pi over 12 and then minus 1 over 6 plus 1 over 6 ln 2. And then everything becomes 0 once you put in 0 here. So we'll leave it at that. And then we will just multiply out and simplify. So you get 5 pi squared over 36 plus pi over 18. One minus ln 2. Yeah. Any equivalent form to this. Okay. And ln 2 is less than 1, so yeah, that's fine. Okay. That'll be the volume. Okay. So usually I would just stop the video here, but this time around I will be finishing the entire thing. So I think there's only 5 more questions, and question 8, question 9 are quite easy. So I think we can do this. Although, yeah, just give me 1 minute. I'll go to the bathroom and I'll pick up right where I left off right after this. Okay, welcome back. Alright, so we're going to go through, I think there are 5 questions left. So questions 8 to 12. Okay, question 8, complex numbers. It's quite a simple question actually. The complex number a plus I is a root of this equation. A and b are real. Okay, so for this, since coefficients, so we use the rational roots, right? The real roots, the conjugate roots thing. Since coefficient of the polynomial, we have a minus I is also a root. So therefore, z, actually because it's a quadratic, I'm going to use sum of roots. Sum of roots will be minus b over a, so that is 2 root 2, which is actually 2a, so a is root 2, and product of roots is c over a, which is just b. So a plus I times a minus I is a squared plus 1. So yeah, so b is 3. Yeah, simple. Okay, of course you can do the traditional way if you don't know what is sum and product of roots. Okay, 8 part 2. I hope nobody really needs me to show you how to do this part. F negative z is negative z power 6 minus 3 negative z power 4 plus 11 negative z squared minus 9. Then, since it's an even number, we get z power 6 minus 3z power 4 plus 11z squared minus 9, which is exactly f of positive z. Hopefully you could have done this yourself, but you know, just to be complete. Okay, 8 part 3. Given that this is a root, okay, so this is actually quite easy because you notice that a plus I and a minus I are different, are not negatives of each other. So we know the quadratic factor is z squared minus 2 root 2z plus 3 equals 0, is a factor. Then we also note that by the part 2, we can replace z by minus z because the two roots of this factor are different. We also have z squared. We replace z by minus z plus 2 root 2z plus 3 is also a factor. Okay, so that will also be a factor. Okay, so now we let fz. Actually, I shall write out the whole thing because I need to see it anyway. Z power 6 minus 3z power 4 plus 11z squared minus 9. We're going to let this be equals to, or identical to, z squared minus 2 root 2z plus 3 times z squared minus plus 2 root 2z plus 3, and then finally z squared plus cz plus d. And we are given that the coefficients of the factors are all real, so where c and d are real numbers. Okay. So one immediately finds that d is negative 1. We compare the coefficients of z to find c. That might be one of the easier ones. So to compare coefficient of z, I take negative 2 root 2 times 3 times d, so that I get 6 root 2. I repeat the same with 3, 2 root 2, and negative 1, so I get minus 6 root 2. Finally, 3, 3, and c itself, plus 9c equals to 0, so therefore c is 0. Okay, so yeah, and then go ahead and answer the question from there. Okay, let's just write down z squared minus 1 as the last factor. Okay, question 9. E power x squared y equals to ln x squared. By the way, this is equivalent to 2 ln x. So we will differentiate both sides with respect to x. And if I differentiate if I keep ex squared first, I will get, actually no, I'll differentiate y first. So I get, no, I'll differentiate e power x squared first and keep y. If I differentiate ex squared, I'll get 2xy ex squared. Okay. Then I keep the ex squared and differentiate y, so that I get e power x squared dy dx. And if I differentiate 2 ln x, I get 2 over x. Okay. But take note, y is ln of x squared divided by e power x squared y. No, just leave it like that. No y there. Okay. So replace y at the top by that, so that I get 2x ln x squared, and the e power x squared cancels out. so that I get plus e power x squared dy dx equals to 2 over x. Okay? Find the equation of tangent at C at the point P where x equals to 1. So, by the way, if it feels like the past few questions have been giveaways, I think it's because of like the last 3 questions, and I will show you that in a bit. Hwa Chong is quite notorious for having difficult block tests, but surprisingly, their prelims are more manageable. At x equals to 1, what is the value of y? Uh, the value of y will actually be ln 1 divided by e, so that's 0. And what is the value of dy dx? Well, if I put x equals to 1, this becomes 0. I have e dy dx equals to 2, so it's just 2 over e. So tangent at P is just the line y equals to 2 over e times x minus 1. Very simple. And how to find the coordinates of Q? We use GC. So you notice that you can actually just divide e power x squared on both sides to get y in terms of x, and you plot that graph in your GC, you plot the same line in your GC, you can find the coordinates of Q very easily. And I won't show you how to do that. Hopefully you know how to do that. You will get negative 0.49516, and I think the y coordinate is negative 1.1001. Okay, to phi SF. Okay, nice. For the part 3, you can, if you want, you can do a sketch of the curve, but for me, I kind of understand what's going on already. And by the way, this acute angle thing has come out for A levels before, so I do believe it is possible for it to come out. It is not it's not an uncommon thing to come out lah. So acute angle will be, first of all, one needs to find dy dx at Q. Okay, and if you do that, you will get negative 4.2503. Okay, by your GC. And for this, the angle, so the required angle will be 180 degrees minus inverse tangent of 4.2503, which is the compensating for the angle formed by Q, by the tangent at Q rather, and then minus tangent inverse of the gradient at P, which is just, it's just 2 over E. Okay? And this is less than 90, and this is less than 90 degrees. But take note, be careful, because your GC is, by default, is on radian mode. So you may need to convert your answer to degrees by letting 180 degrees be pi over 2 first. But once you do that, you should get 66.9 degrees as your answer. And because it's in degrees, always 1 decimal place. Okay. Question 10, vectors. It's actually not too difficult of a question, just that there's an annoying part, and I'll explain that in a bit. So referring to origin O, position vectors of A and B are that the area of triangle OAB is 16 square unit and mod B is 5 units. Okay, so you can draw the diagram if you want, but I will skip drawing the diagram. So area of triangle OAB is 16 square units. What does this actually mean? It tells you that A cross B is actually 2 times 16. Because A cross B, one of the geometrical interpretation, is twice the area of the triangle, right? So this is 32. Okay? So A cross D. So actually, if you read the question, D is actually just B cap lah. Okay? So this is 1/5 of A cross B, which is just 32 over 5. And what is the geometrical interpretation? What is it whenever you have A cross D cap? It's the shortest distance, right? So it is the shortest distance from A to OB. Or you can also say perpendicular height of the triangle OAB with respect to the base OB. Also can. Okay? It is given that mod A is 8 and AOB is an obtuse angle. So let's see where that takes us. What is A dot B? Okay, so we know that so angle AOB is obtuse, meaning to say sine angle AOB is actually A cross D, mod A cross D, I'll put the mod here, mod A cross B divided by mod A mod B. Okay, and this is 32 divided by 8 times 5, which is 4 over 5. So sine angle AOB is actually 4 over 5 positive, since angle AOB is obtuse. And what is the value of cosine angle AOB? Well, it will be negative, right? So use Pythagoras or whatever, it will be negative 3 over 5. And then you can use that to find A dot B. A dot B is mod A times mod B times cosine angle AOB, which is negative 24. Okay. Okay, here's the slightly annoying part. So point C divides AB in the ratio mu to 1 minus mu. Mod C is root 4 1 divided by 7. Okay, so this question is actually not too bad if you know the working. C, by ratio theorem, the vector C has the position vector of, I think, 1 minus mu times A plus mu B. Okay? So how to find OC? How do I consider the suitable scalar product? Well, I am given mod C. If I dot a vector with itself, I get the square of the mod, right? Furthermore, I know what is A dot B. So I can actually do C dot C. So where does that actually take us? Okay, if I do this, I'll get 1 minus mu square times mod alpha square. Mod A square is 64, so I get 64 1 minus mu square. Okay, then I will have 2 times of A dot B, so, and then multiply the mu and 1 minus mu also, so I get negative 48 mu times 1 minus mu. Okay, and then mod B square is 25, so I get 25 mu square. Okay, and this is equal to mod C square, but I will simplify this a bit first. So I already worked it out on pen and paper. You will get 137 mu square minus 176 mu plus 64. And equate this to mod C square, which is 401 divided by 49. Okay, as you can see, the numbers are not very convincing. If you simplify, you get 6,713 mu square minus 8,624 mu plus 2,735. So bring all the constants over, you get 0 here. This is a quadratic equation in mu. And it looks like you've gone horribly wrong because the numbers are horribly terrible. But it turns out that this is correct. And this actually factorizes. And if you don't believe me, use your GC to check this. Because there's polyroot finder on GC, right? You will get 959 mu minus 547 and 7 mu minus 5 as your linear factors. Okay? This is a very ridiculous number, I know, but it is correct. So mu equals to 547 divided by 959, or mu equals to 5 over 7. Okay, 5 over 7 is not that bad, but 547 over 959 is pretty ridiculous if you ask me. Okay, so of course answer the question. OC So by ratio theorem, I can either have 1 over 959. So I get 1 minus mu, so I get 412. So I get 412a plus 547b. Or I have the much more reasonable one. I will factor out the 7. So 1 over 7 of 2a plus 5b. So those are your two possible position vector for OC. Oh, this one. Okay, question 11. Okay, so it's a maxima minima. So basically we want to find you can read the question yourself. Basically what we want is to find the area of ABCD in terms of X. So we can let P be the intersection of AC and BD. So you can do this in whatever way you want. Triangle ADB is half times 2x. Half times based on height. The height being by Pythagoras is square root a squared minus x squared. And triangle DCB is by the same process, half 2x square root b squared minus x squared. And I'll let you figure out what this is. Okay, so these two you add together will give you k. Alright, I'll let you simplify and show that it simplifies to that. I'll leave it at that because I'm a bit lazy now. 11a part 2. Okay, so we want to maximize k. So the working for this is a bit Here's how I'm going to do it. I'm going to consider k equals to x, factor out the x, and write square root a squared minus x squared plus square root b squared minus x squared. Okay, so what happens now? Dk dx. Okay, if I'll keep the x first, if I differentiate this, actually no, I will keep the bracket term first, because if I differentiate the x, it's just 1, so I get root a squared minus x squared plus root b squared minus x squared. Okay, so far so good. Now I need to differentiate this. If I differentiate root a squared minus x squared, I'll get power negative half, power half, and then differentiate x squared gives me negative 2x, so the 2's cancel out, but it becomes negative. But there's an x on the outside, so therefore it actually becomes negative x of x over root a squared minus x squared plus x over root b squared minus x squared. Okay? And yeah. How do I simplify this? It seems very complicated. We're going to have to combine the denominators. So if I combine the denominators on this side, I'll multiply top and bottom by root a squared minus x squared. Alright, no, sorry. This term multiplied by root b squared minus x squared. This term multiplied by root a squared minus x squared. And I'll show you where that takes us. So that I get root a squared minus x squared plus root b squared minus x squared minus x squared. And if I combine this to a single fraction, I get root a squared minus x squared plus root b squared minus x squared divide by the product of those two. And hopefully you will see that this is starting to look good. Okay? Because I can actually factor out the a squared minus x squared plus b squared minus x squared. And this gives me 1 minus x squared divided by the square root of a squared minus x squared and b squared minus x squared. Okay, so yes, very nice. So we now let dk dx equals to 0. And for this, we will use how do I explain this? This term will not be 0. So we will first assume that A is not equals to B, because if A were equal to B, then the problem will be a lot simpler already. Yeah. We have assuming A not equals to B, because if A equals to B, root A squared minus x squared plus root B squared minus x squared equals 0 when x equals to A, give k equals to 0. So we don't consider this because that would just give us a 0k, which is obviously not what we want. So we need to have x squared be equals to a squared minus x squared, b squared minus x squared. Okay? And I know it's tempting to just square root both sides and say fourth root of that, but that is actually not going to be a simplified answer because I can do this. X power 4 is the square of this, which is x power 4 minus a plus b, a squared plus b squared rather, x squared, and then plus a squared b squared. And therefore, we need a squared b squared equals to a squared plus b squared x. So therefore, x squared is a squared b squared, a squared plus b squared. And finally, the value of x will be ab divided by square root a squared plus b squared. Wow, a lot of work. Luckily, the Hwa Chong setters knew that this was quite a bit of work, so we do not need to showcase a maximum for this value. Find the length of the wooden stick AC in terms of A and B when K is maximum. Okay, for this, the last two parts are quite simple if you can get the second part. So for this, we have AC equals to, as I defined the point P earlier, AP plus PC. And AP is a squared minus root a squared minus x squared. So that I get root a squared minus x squared is a squared b squared divided by a squared plus b squared. And then similarly, PC is b squared minus a squared b squared divided by a squared plus b squared. If I simplify this, I will get a squared times a squared plus b squared divided by a squared plus b squared when I combine into a single fraction, which becomes a power 4 minus a squared b squared. So the a power 4 plus a squared b squared, sorry, which cancels the a squared b squared over here. So I'm just left with a power 4 over a squared plus b squared, square root the whole thing. Same argument applies to the other side, so that finally I get actually, how about I write it out? I'll get a power 4 divided by a squared plus b squared plus root b power 4 divided by a squared plus b squared. So that I get a squared plus b squared divided by root a squared plus b squared, which simplifies to just root a squared plus b squared. Yeah. And what is the deduce the angle between the straws AB and BC? Okay, so this is also not too tricky. So for this, note that by observation, we have AB square plus BC square, which is a squared plus b squared, which is actually AC squared, right? So meaning Pythagoras theorem applies here. So Pythagoras theorem. So therefore, angle ABC equals to 90 degrees. Yeah. So that will be the observation to make. I think it's really cool. Part B is the connected rates of change. Okay. So there's a lot of context for this question, of course, but the crux of it is that we want to find the rate of change of theta. So if you use a bit of trigo, you will realize that okay, let me define this. Let d be the distance between PQ. Okay, so we notice that, so of course by this definition, dd dt is 12 over 5, and d itself is 30 cotangent of theta. And just so that my q doesn't look like theta. Okay. So how do I solve this? I want d theta dt, so I find dd d theta. Differentiate cotangent is negative cosecant square, so you get negative 30 cosecant square theta. We find dd dt to be dd d theta times d theta. Sorry, we want d theta dt. Sorry, because rate of change of theta, right? D theta dt is d theta dd times dd dt, which is sine square theta of negative sine square theta over 30 times 12 over 5, which is 12 over 150, which is 3 over 25. No, 2 over 25. Negative 2 over 25 of sine square theta, is it? Yes, okay. So when Sam has let out 10 root 10 of the string, when OQ, so what is OQ actually? You'll notice that OQ is 30 cosecant theta. So 900 cosecant theta, 900 cosecant square theta is 1000. So sine square theta is 9 over 10. So at this point, d theta dt will be equals to, yeah, that's it. 9 over negative 9 over 125. So therefore, the rate of decrease, note that the d theta dt is negative, so the rate of decrease is positive. It is 9 over 125 radians per second. Yeah, always leave it in radians for calculus. Okay, cool. We've come to the final question. Uh, this is the kinematics motion. Okay, so we have a cargo drone to unload the first aid kit. Some very modern procedure. Okay, the important part for the first part is the speed of the kit v meters per second is the rate of change of distance of the kit measured vertically away from the drone in respect to time. So what is the differential equation relating v, x, and t? Well, it's actually just v equals to dx dt. That's it. Sorry. The motion of the first aid kit is modeled by this differential equation in terms of x. So show that this differential equation can be expressed in terms of v. So what is dv dt? dv dt is actually just the derivative of v with respect to t, which means it's the second derivative of x with respect to t. So d2x dt squared, which we are given is 10 minus alpha dx dt squared. But v is dx dt, so this is 10 minus alpha v squared. Yeah, that's it. Okay, we're going to solve the differential equation now given these conditions. Okay. So we're given dv dt is 4.375 and v is 1.5. So we can use that to find alpha. So dv dt at v equals to 1.5 equals to 10 minus 2.25 alpha equals to 4.375. Of course, you can go ahead and work out what the value of alpha is. I believe the value of alpha is 5/2. Yeah. Just checking my own paper working for this. Okay. So it is now time for us to solve this differential equation, and we will rewrite it. So notice that 10 is 4 times of 5/2. So I shall write it as 2/5 dv dt equals to 4 minus v squared. So we can obtain the integral of 1 over 4 minus v squared dv equals to the integral of 5/2 dt. The left hand side has a standard integral that you can find in MF26. So you will get 1 over 4 ln mod 2 plus v divided by 2 minus v equals to 5/2 t plus c, where c is the arbitrary constant. What is 2 plus v divided by 2 minus v? Well, we can multiply 4 on both sides, but then we need to deal with the modulus. To avoid doing the modulus, I shall actually just make a new variable. So if I multiply 4 on both sides, I'll get a e power 10t. And what is a? A is actually plus minus of e to the power of 4c. Yeah. So I can get rid of the modulus without actually having to solve. Although if you actually go ahead and solve c, you will find that it's positive. So we will now sub in the condition, which is t is 0 is v is 0. So when t equals to 0, we have a equals to 1. That's it. Because 2 plus 0 divided by 2 minus 0 is a e power 0, which is 2/2 equals to a, so a is 1. Okay. So we can now solve the equation quite easily. So we will try and factor out the v here. So v e power 10t plus 1 equals to, then bring everything to the other side, so we get 2 e power 10t minus 2. And then of course you can divide both sides by e power 10t plus 1, so that I get 2 e power 10t minus 2 divided by e power 10t plus 1. We can multiply the top and bottom by e power negative 10t to get the expression 2 minus 2 e power negative 10t divided by 1 plus e power negative 10t, which is exactly what we wanted. K equals to 2, m equals to 1. sketch the graph of v against t, describe the behavior of dx dt and d2x dt square in the long run. Okay, graph of v against t is it's actually very simple. So there'll be an asymptote of v equals to 2, and you can actually find this by observation. The reason that they want you to write in this form is so that it's easier to find the equation of the horizontal asymptote. As t goes to infinity, your e power negative 10t goes to 0. So you get 2 over 1. Okay? So your curve is actually just an increasing function, and it approaches this asymptote. That's it. Okay? So this is the graph v equals to 2e 10t minus 2 divided by e power 10t plus 1. Or rather, I will write it in the form they requested. Oh no. I think my Microsoft Whiteboard is starting to lag because I have too many things on the same page. I think this is also one of the reasons why I split it into two halves. Okay, this is t and this is v. And it passed through origin since when t is 0, v is also 0. Oops. Okay, can. So this is let me just actually say that this is 10 part 4, 12 part 4. Seems to have sped up for some reason. Okay. So what does the dx dt? So as t tends to infinity, what happens to dx dt and d2x dt square? Dx dt, you can see from the graph that v is dx dt, by the way, so it's an increasing function. You can clearly see that dx dt increases and approaches 2. Okay, so I think you need to state the limit as well as which direction it's coming from. And you can see that the gradient is increasing at a decreasing rate, so therefore the 2x dt square is decreasing. So decreases and approaches 0. Okay? And of course, those of you who take physics, you will know that this is what we term the terminal velocity, because in this case, the 2x dt squared is actually the acceleration. So we will reach a point where we have 0 acceleration, our velocity is a constant, that will be terminal velocity. So you physics students will know about this, but if not, that's okay. Show that the area under the graph can be bounded by the lines t equals to 0 and t equals to capital T can be expressed as this. Okay, so of course for this part we need to integrate. So 12 part v, this is actually just the integral of 0 to t of what was the curve? It was 2 minus 2e power negative 10t divided by 1 plus e power negative 10t dt. How do I integrate this? Well, there's a few ways you can integrate it, but all of them have the same approach. Oops. Pretty much every way of integrating this is the same approach. We want to use f prime x over f of x. So one possible way is to consider writing it in the form of a constant and something that we can find. So we will get, if I change this 2 to negative 2, actually no, what I will do is if I add 4 e power negative 10t, I'll get 2 plus 2 e power negative 10t, so I'll get 2 minus 4 e negative 10t divided by 1 plus e power negative 10t, okay, dt. So if I integrate this, I will get, wait, why did I put 2 here? It should be t, big T. So we will get 2t minus, now the derivative of 1 plus e power negative 10t is negative 10 e power negative 10t. But we only have a negative 4 here, so I'll plus 2 over 5. Okay, so that I get ln mod 1 plus e power negative 10t. And then this goes from 0 to capital T. And strictly speaking, we actually don't need the modulus. You can go and check that for yourself. But because we are evaluating a definite integral, it doesn't matter. So we will get, you'll get 2 capital T plus 2 over 5 ln capital T. 1 plus e power negative 10 capital T rather. And when we take the 0, the 2t is 0. 1 plus e power 0 is 2, so you will get minus 2 over 5 ln 2. But we need a single ln term. How do we do that? Well, I can factor out 2 over 5 and multiply by 5t. But what is 5t? It's actually ln e power 5t, right? So I can actually do this. Yeah. Plus 2 over 5 ln 1 plus e negative 10 capital T minus 2 over 5 ln 2. And then we can use logarithm properties to combine everything together. Since we have a 2 over 5 in everything, I can factor it out. So I get e power 5t times 1 plus e power negative 10t divided by 2. And if I do that, I will get the e power 5t plus e power negative 5t divided by 2. And the positive integer beta to be determined is 5. Okay? And what can you say about this in the context of the problem? Well, area under the curve of the V graph, right? Well, we learned from eMath, and I think a few other places like physics or this, that the area under a speed time graph is the distance traveled, right? So this is the area under a speed time graph, so therefore it must be the distance traveled for the first aid kit. So it is the kit will be moved. Okay, so distance traveled by the first aid kit in the first t seconds, capital T. Okay, yeah. So that's it for Hwa Chong paper 1. I'll combine the 2 part videos together, so this should be a roughly 1.5 hour long video. As I said, I will try to get the paper 2s for the papers that I have to do up before the paper 2 on Friday. Next week, Friday. That would be the 11th of November, if I'm not wrong. So all the best to everyone who's taking the H2 Maths A-level paper, as well as for the rest of your subjects, of course. And yeah, I'll see you guys next time. Take care.